Construction industry likes standardization and prefabrication, and to model it efficiently, you need to design every part and assembly in a local access system. Let's reopen our desk model. That is currently only a single part, and start detailing it as an assembly. Create a product and rename it. Insert below it the part representing the desk. And rename the part with characters SK, for example, for skeleton. Remove instance name, as this part will be used only once, and fix it in space under the product. Then create a geometrical set to capture the local positions of each of the 4 legs. Rename the geometrical set and launch the access system creation. Be careful to uncheck this option for the access to be created inside the geometrical set. Then create the access system for each leg. Remember that you can change the creation of features with a double click on a command. The panel will reopen after you click OK. And to close the panel, click Cancel after the last axis creation. Activate the product and insert a part that will be used to design one leg of the table. Rename this part, reference title, instance title, and 3D shape. Before starting the design of this leg, we'll locate it on the first leg axis system using an engineering connection. The procedure for this might look a little tedious, but it's because it supports many more functionalities like kinematics or clash detection. Specify which part should be moved, select the 2 axes in the proper order, set relative position to 0, validate. Disregard the clash management message. And now you're ready to start the design of the part. Model the leg as a volume, reduce the elevation of 50 mm for the tabletop thickness, hide construction elements, rename geometrical set. Reactivate the product. And start assembly pattern, which is probably the most productive command at product level, because it's capable to instantiate the same part multiple times under a product, according to a series of axis systems found under the geometrical set of the part used as the skeleton. To demonstrate the capacity of assembly pattern, let's add 2 more axis systems under the geometrical set. When you reactivate the product level and update, 2 new instances have been created in the tree. And reversely, if you delete these access systems inside the geometrical set after updating your model, the instances will be removed. For the design of the tabletop, you can proceed the same way. Create a geometrical set to store the local axis system of the tabletop, rename it, create the axis system, then create the part that represents the tabletop. Rename reference title, instance title, and 3D shape. Relocate the part on this axis system with another engineering connection. And finally design the tabletop in its local access system, with an external reference to the table contour publication. Set color, hide construction element, rename geometrical set. And hide the 3D shape of the skeleton part. This sequence shows how you would create a drawing of the tabletop part for a supplier, for example. Insert a drawing under the part, double-click on it, and start the creation of the views like this. Because the part is designed in its local axis system, the geometry appears in the middle of the view, and not in the position it has under the assembly, which is very handy when you automate the generation of drawings. It is not obvious in this table example, but you will see a more relevant use case if you follow this YouTube link. An explanation on how to automate generation of drawings. Rename the drawing. Make sure the model is up to date and save. This design methodology, where a part under a product drives all other parts of the assembly, is widely used and commonly known as skeleton methodology. It's convenient because you can recursively detail your model more and more and create multiple variations of your assemblies with very few different references of components, but only if they are all designed in their local access systems. And if your engineering is good, you can even make symmetrical assemblies that are in fact only rearrangements of the same components. Back to our model of desk. To replace it under the desk with coder assembly designed in previous step, we'll recreate the publication at assembly level to redirect the link after replace. At assembly level, create another publication of the tabletop contour like this. Then open the desk with coder assembly and replace the part representing the table by the assembly. Publication will redirect the link inside the assembly. Then hide useless elements, update and save. Conclusion. Start the design inside one single part. Once ready for assembly detailing, insert it below product, lock its position in space and use it as a skeleton. Identify as many identical items as possible and use assembly patterns to locate them. Design them in local access system. For unique items, you can use external references, and you can also design them in a local access system to simplify drawing generation.